Hello and welcome to Security Scan. I am Vishal Dahiya, and this week we will talk about HSTDV, Hypersonic Technology Demonstrator Vehicle. Last week, India test-fired Hypersonic Technology Demonstrator Vehicle, that is HSTDV, from Integrated Test Range in Balasore district in Odisha. With Scramjet engine, the HSTDV can cruise at Mach 6 speed and have multiple civilian applications. It can be used for launching satellites at low cost and long-range cruise missiles. A Scramjet engine has the capability of operating at hypersonic speeds and allows supersonic combustion. A successful test of this hypersonic technology transporter vehicle is likely to bolster the development of a hypersonic cruise missile, the BrahMos 2, that is currently under development with Scramjet technology. Other nations that have successfully demonstrated this technology are United States of America, Russia, Japan, and China. For more on this, we're joined by a distinguished panel of guests today. Let me start by introducing them to you, beginning with Retired Lieutenant General V.K. Saxena, Distinguished Fellow at VIF. We also have with us Retired Group Captain Ajey Lele, Senior Fellow from IDSA. And we have with us Senior Journalist Mr. Manu, Pubby, the Senior Editor of Economic Times. Welcome all of you gentlemen to Rajya Sabha TV studios. Let's first begin with try and explain to our viewers what exactly do we mean when we talk about the hypersonic technology. So, General Saxena, let me begin with you. What is exactly hypersonic technology?
Sir, hypersonic technology or hypersonic weapons, they have certain characteristics which make them so lethal and unstoppable. First of all, by definition, these are the types of weapons which can fly at a speed of 5,000 km per hour or more than that. That is Mach 5. As also, they can keep low, that is endo-atmospheric region, up to below 90 kilometers. And thirdly, they do not lose maneuverability in flight. That means they are the three main characteristics. Now, what is all this capability mean to a weapon system? There are two types of hypersonic weapons. One is called the hypersonic cruise missile. One is called the hypersonic glide vehicle. Now, what is these two difference? Hypersonic cruise missile is a cruise missile, like we know BrahMos is a cruise missile, which is a low-level missile which can fly long distance with precision. Now, in hypersonic cruise missile, it can do the same job, but at the speeds greater than Mach 5 and more, and also remaining low. Second is hypersonic glide vehicle. Hypersonic glide vehicle is a vehicle which carries on board a mother rocket, which boosts it to a certain level, and in that boosting phase, it takes it to such high speeds that shock waves are created.
Supersonic speed.
Yes, supersonic. Shock waves are created. These shock waves are utilized by the lifting surfaces which are there on this vehicle to reduce the drag ratio and lift to drag ratio, and the vehicle propels at the speed of 5, 6 up to 10 Mach. Now, these are the type of characteristics, but what is it which makes it such a lethal and unstoppable weapon? First of all, a weapon like this, which is a hypersonic weapon, can hit anywhere in the earth, any part of the earth within 1 hour. Okay. Imagine a weapon system approaching, or a weapon approaching at the speed of Mach 5, Mach 6, Mach 10. There is simply no time for any ballistic missile or any missile defenses to detect it, to identify it, to alert our weapon system, to make our own missiles become active and take it on in the phase in which it is coming.
Okay, so much potent than the ICBM.
Unstoppable. Secondly, they are undetectable. Why? Because if you talk of the ICBMs or others, they go into space. When they go into space, they follow a ballistic trajectory. Now, ballistic trajectory is highly predictable trajectory, and the enemy's surveillance system or the defender surveillance system can make out that this is a vehicle which has been launched and it will be following this course. It will re-entry at so and so point. It is carrying MIRV or not. This technology of hypersonic weapons are non-ballistic trajectory. They follow a non-ballistic trajectory and therefore most difficult to detect. Third is their punch, which is created is the type of kinetic energy which they carry. Now, imagine a force. I say hypersonic weapon do not even have to carry warhead. A weapon system coming, a weapon being launched at 10 Mach, like for example KH-46B2, Russian hypersonic weapon, they are claiming it to be 20 Mach. Imagine a vehicle at that speed coming and doing a catastrophic collision at the target. It is said that even if a vehicle of having a hypersonic speed of only 1 kg at Mach 6 has an effect of 36 times more than the effect of a normal conventional missile that is there.
Okay.
And last point which is there is unpredictability. Why unpredictable? Now some weapon is there which I am not able to detect. It can move at such tremendous speeds and it can change course so fast that by such weapons can keep a large amount of area under threat. A hypersonic weapon is detected, it can hit here, it can hit somewhere else, it can hit. So the
it can be maneuvered as well.
Defender gets alarmed over and is threatened over a very large area.
Okay.
So these are the threat of hypersonic weapons, which is saying, like President Putin has said, unstoppable and totally undetectable, his missile.
Okay.
So this is what is hypersonic.
Okay, so that's the weapons technology part of it when we talk about hypersonic technology. But of course, there are civilian use as well, and one of them being talked about is we can launch new satellites with a minimum cost. So the cost factor is there as well. Captain Lele, in terms of the civilian use as well, obviously we would like to elaborate on the weapons technology, but in terms of civilian use also, there is a lot of potential as far as hypersonic technology is concerned.
You see, it has got mixed usage, I will say. Civilian use is essentially for launching of satellites. Again, there are certain amount of limitations. When you talk of a hypersonic technology, it is not only the speed part of it. When we talk at 1 Mach, that means it is equivalent to a speed of a sound. So you're traveling at a speed of more than 5 Mach, then you are entitled to call that particular system as a hypersonic system. But you need to look at a frequency also. Sounding frequency also is important, which is supposed to be 1000 million hertz. Then altitude and temperature also makes a lot amount of a difference. So as you go up into the atmosphere, the speed limitation gets slightly reduced. So all these aspects are taken care when you are going to launch a satellite. The limitation of these types of systems is that it carries what we call a scramjet engine. Now scramjet is essentially what happens is that whenever you carry something out into the space, you require a fuel for it. Now it consists of two parts. You got a oxidizer also and you got a igniter also. So particularly the oxidizer part, which goes out into the space or other regions, consists almost of 70% of the weight. So here the oxidizer is not there, you are just picking up the oxygen from the atmosphere. So as you go up, this sort of a technology has got limitations because the oxygen limitations are there is hardly any oxygen available.
Okay.
So particularly for launching satellites into low Earth orbit, these technologies are more useful. Other than that, it has got more utility as far as armed forces are concerned.
Okay, so in terms of weapons, hypersonic technology will be much more potent and more useworthy out there. Let me bring in Manu here. Manu, your views on the hypersonic technology per se. Both the gentlemen have explained in detail about how it can be used in terms of weapons and civilian use as well. But what's the world scenario?
See, that's the interesting thing. India came on to the ICBM category at least 20 to 30 years after the rest of the world. Now, hypersonic technology is the next generation of missiles. All next generation missiles will be on this technology. So, for us to leap into this at the global stage is very important. And I think what our scientists are trying to achieve here is to leapfrog us a generation ahead. So, look at the world scenario. China already has this. They demonstrated it. They are making a nuclear capable missile using this technology. The Russians do have it. The Americans have demonstrated it as well. So we can't fall behind on that league. We already a few years behind the Western technology on this, but I think with this demonstration, I remember ISRO did a similar test about 2 years ago, which they demonstrated a scramjet engine for space launch. But getting this is basically going to empower all your next generation Agni 1, 2, 3, 4, 5. They're going to be obsolete in a few years. And this technology, I think, will have applications not only to deliver nuclear weapons, it will also have applications for us in terms of air-to-ground strikes. Remember the speed which it has, it makes this missile unstoppable. And for next generation warfare, where other countries will have missile defense systems up there, this is absolutely essential.
Okay.
And I think we are on the right path on this. This is a technology which has been under discussion and under development for at least a decade in India now. And it is good that we've come to a stage in which we are starting to test it. And hopefully very soon we should have a system which can be deployable.
Okay, that's interesting. A technology which not many countries in the world have. But General Saxena, one aspect which Captain Lele also pointed out is the efficiency of the Scramjet engine in the higher orbit, and that's what the limitations which he spoke about make it not that worthy in terms of the civilian use. But that's not what exactly would hinder its use as far as weapons technology is concerned.
Yes. As rightly brought out by Ajey was talking about the scramjet engine. Normal this missile technology, they use ramjet engine, a normal jet propulsion. Ramjet engine means what? An engine in which when it is forced against the air at a high speed, then what happens? The air rams against that engine. The air is pulled inside and mixed with the fuel in the combustion chamber and burnt. The hot gases are made to pass through a nozzle, and that creates a forward thrust forward. In the case of a normal ramjet engine, the air which is being mixed with the fuel and combustion which is taking place is not at the supersonic speed. It cannot sustain supersonic combustion. But the scramjet technology, the name itself is the supersonic combustion ramjet technology. In this, the combustion itself is taking place at a supersonic speed of the air at the supersonic speed, due to which the escaping gases are also at supersonic speed. That's why the speed which of escaping gases creates that sort of a velocity, that sort of a momentum, that the forward momentum is that high. Now, when we are talking about this technology, scramjet technology, and this test of DRDO, it should not be seen as just one event which has somebody is debating it happened or not happened. The story of this test started, sir, in 1998, 12th February 1998. The BrahMos was, the JV was signed between the DRDO and the NPO Machinostrovnia of Russia. At that time, we produced the first BrahMos. The first BrahMos, the 2001-4, the land version came out. 290 kilometers is the range, and the speed was 2 to 3 Mach. At that time, what was happening? Thereafter, we continued to follow. In 8 and 9, the ship version came, and in 12-13, the submarine version came, and the 17 lately, we also had its launch from Sukhoi 30. That time itself, by the turn of the century, the scientists were talking about the hypersonic missiles as such. If you talk about program ED, our ballistic missile defense program, it is on in two phases, phase 1, phase 2. In phase 1 and phase 2, their missiles are endo-atmospheric and exo-atmospheric. In the phase 1, which was up to 2000 kilometer range, the endo-atmospheric missile is PAD, Prithvi Air Defense, and Prithvi Design Vehicle, PDV. And in phase 2, their AD1 and AD2 were supposed to be in hypersonic range. That means around the turn of the century, we were thinking of hypersonic that time. But imagine now, once we joined the MTCR, the range is increased to range now, we are talking about 600 kilometers, BrahMos ER. But the most important is BrahMos 2. When we are talking about hypersonic range of 450 kilometers, speed of up to 7 to 8 Mach. Okay. What are we trying to achieve? We are trying to achieve of this weapon in terms of its unstoppability, undetectability, tremendous kinetic energy, and this whole game of hypersonic weapon. We are well into our game. Now China, everybody says China is very high. China also started sometime DF-17, August 2017. They first fired their DF-70. Before that, 13-14 firing was going on. In December 18, they fired DF-41. And now everybody talking about the Skari, their hypersonic aircraft, Zinkong or Starry Sky went up to 10 Mach. Then Russia, Avangard. Even US is actually a little far behind. In 1960, they're ahead of all these people. In 1960, they made their B-7 strategic bomber, which was an hypersonic, that time 2 to 3 Mach range, but it failed. But today, they both realized, US realized. In fact, you hear his statements of the Assistant Secretary of the Defense. They said that we need to catch up on the hypersonic age. That's why they are building a weapon called ARRW.
So this is the new technology, yes, which everybody is talking about. But Captain Lele, going by what we've spoken about so far, it looks like the momentum, the velocity, the kinetic energy of this sort of technology and this weapon makes it very lethal and very potent. So in that ways, this is going to be that ultimate weapon which everybody talks about.
You see, this technology has been rightly coined as a game changer. Few people call this technology as a new stealth also. Because essentially what happens is that today, if you really look at the countries which are developing these missiles, apart from Japan, all countries are nuclear weapon states. All countries have got a missile defense shield available with them. So they got a nuclear triad where they're putting their missile defense shield over there. Now, idea of these types of missiles is that they will be able to penetrate any sort of a existing missile defense shield. So, in a sense, it becomes the issue of a nuclear deterrence slightly redundant in years to come. Because if your missile defense shield is not able to take care of an incoming missile, there is no defenses which are available with a particular country. So, the research in this arena right now is happening to a level where they want to increase the speeds. Just to put it simplistically, we called few missiles as subsonic, that is 0.8, then you got a transonic, then you got a supersonic, where you had, if you remember, the Concorde aircraft which used to fly. It used to take hardly 2 hours to travel a distance, say, between Delhi to London. Then we are now in the range of hypersonics. So, with this much amount of a speed, if a missile attacks a particular target, they are actually unstoppable. And there are no countermeasures which are available, at least at this point in time, because everybody is trying to develop a technology. Americans are claimed to have developed a technology where they can, their missile defense system, the modern missile defense system, can address the speeds of around 8 Mach, but it is still not a proven system. So, right now the countries which are essentially nuclear weapon states are putting their money to ensure that the lethality of their nuclear deterrence or a deterrence per se will get further increased by using these types of technologies.
Okay. Manu, would you agree that this is actually the game changer?
It is definitely, and even beyond nuclear. I mean, look at the conventional aspect of this missile. Let me give you a very simple scenario. You know, a country A, say India, detects a terror training camp across the border, which is say 100 kilometers inside. In the conventional style now, you will probably take off aircraft from India, they will fly across and strike. That gives a lot of time to the enemy to understand that something is coming. You know, even a 5-minute delay can mean a person or target escaping. With this kind of technology, the speed that it goes, I mean, death is certain and the timing is certain. So you can actually act on real-time intelligence.
And this weapon is unpredictable as well, because it can be maneuvered.
Exactly, it can be maneuvered, and plus, if you have an operator on the ground who sees a terror target moving, he can just call the strike in, and the strike comes in so fast, the target can't move out. So it is a game changer even against non-state actors and terrorist organizations. So it will really scare them, this kind of technology, for sure.
Okay. General Saxena, you know, concluding comments from you in terms of the way ahead, the future, because as all of you are pointing out, this is actually a game-changing technology, and there are countries which have perfected this technology, successfully tested it as well. We are on it as we talk, but how do we look at it in terms of the future from here on?
Sir, we should look at the future the way it is progressing. It's a game of progression. We started from a subsonic missile, then we came to a supersonic missile, then we made the world's fastest supersonic cruise missile. Now we are in the hypersonic range. It's only a it's only a method or game of progression. But at the same time, we should also be very, very realistic. What is realistic I am talking about? We should develop our defenses in relation to the threat perception. Now, what is I don't have to go into this detail of our potential adversaries and so on. While the hypersonic technology is very much a game changer, it is required, we are progressing towards it, but we must keep the realism in mind of what hypersonic threat we are going to face in the foreseeable future. What is it which is likely to be impacting upon us in terms of hypersonic missiles, where our ballistic missile defense is there today in phase 1 and phase 2, and where we lack in where is a gap in handling those weapons, and develop the game changer technology to take on the threats which are emerging. There is no point of only putting all the money in only hypersonic technology itself. If we realize that the threat is about this much in this foreseeable future, our ballistic missile technology is taking us up to 5,000 kilometer range, or this range we require to handle this much more. That is the case of realism I am talking about. But as regards the technology per se, this is a technology whose time has come.
Okay.
Whose time has come in ballistic missile defense, whose time has come in calling it a threat in our countering the threat which we are facing in the foreseeable future,
Okay.
and it needs to be developed both in terms of the technology in the civilian use as well as missiles for defense use.
Okay, Captain Lele, the time of this technology has come.
I think time has come. There are 2 to 3 quick points over here. India has already got a missile which is in its inventory since 2011 called Shaurya missile, which travels at a speed of 7.5 Mach. It is a surface-to-surface missile. Other aspect of this technology is that one must understand that these technologies, we may call them as a game changers, but at the same time there is a greater amount of a threat to security from these technologies. These are the technologies which are basically going to increase the arms race also. So one has to look at various aspects. Right now the debate has already started whether before becoming a technology as a foolproof technology, whether these weapons should be banned, or should nuclear weapon states join hands together and say that they will use hypersonic weapons only in a non-nuclear mode. So there are people at United Nations who are looking at these technologies very seriously. So I think India also should look at various aspects before getting into a blind development of these aspects.
Okay, Manu, that's a very significant point
No, it's totally
raised
right.
by Captain Lele there.
I agree, and it takes a lot of money to do this system. It's not free, it's not cheap, and the budgets for such development programs is in the billions. So yes, we should, at some point be at a stage in which we can talk about this at the global level, but to do that we have to demonstrate it. It is the same like in the anti-satellite demonstration that we did. Only after we demonstrate it can we sit at the global table as equals with the other countries and decide on regulation on future aspects of this. So it's very important we demonstrate this and show the world we have this. So when the world comes on to regulate this or put ban on it or whatever, we should be right there and our word should be counted for sure.
Okay, so clearly, as our panelists have pointed out, that the hypersonic technology is a game-changer technology. Time has come for a technology like that, and while some nations have already perfected and successfully demonstrated the HSTDV, which runs on this technology, India is also taking a go at it. We'll keep you updated on all the developments on this, as well as other aspects of this technology and other weapon systems. We'll come back again next week with a different topic and different set of guests. Till then, keep watching Rajya Sabha Television.